Hello, my name is Jeff Orchard, and I will be teaching CS473, also known as Medical Image Processing, in January. So a quick overview of the course. You can see a list of topics that we cover. I'll go over some of them very briefly today. Image segmentation, signal processing. We'll talk a little bit about the theory of signal processing. Then we'll talk a bit about medical imaging sources, CAT scans, MRI. Then I'll talk a little about image enhancement, how we can manipulate images to make them look better and affect what information we can see from them visually. Then we'll spend more time talking about image registration, segmentation, so I'll also describe those a bit right now. Sources of medical images, we'll talk about MRI, magnetic resonance imaging, CT, which is computed tomography. Those will be our focus. We'll spend most time talking about those two, but I'll also briefly talk about PET and X-ray and ultrasound, and we'll even see some data set that are photographic cross-sections of a human body. I'll talk about the physics behind mostly MRI and computed tomography, and we'll also be learning the reconstruction algorithms, how you take the raw data off of those scanners and reconstruct pictures of cross-sections through the body. We'll spend more time on registration. So registration is taking images that are not aligned and aligning them. So pictures of the same thing, but if you overlay them, you can see here these two MR scans are not perfectly aligned. So when you put them together, they don't quite match up. So let me just show you something typical from a lecture. I'll often show MATLAB code. You will be programming in MATLAB. So let me just run this script that demonstrates registration. So here's one image and another image, and you can see they're the same thing, but they're moved. Now if I subtract one from the other, you can see that not all the anatomy cancels out. But if we run this simple optimization algorithm, it can put one perfectly on top of the other, and then everything cancels out. All the anatomical structures cancel out, and you're just left with the noise. So we'll be learning algorithms like that in the course. You can see in these images down here, the images don't cancel out. Even if they were perfectly aligned, they wouldn't cancel out. In this CT image, the bone, this is a cross-section through a skull, the head, the bone is bright, but in MRI the bone's dark. So you can't just subtract the images and expect things to cancel out. You have to do something more sophisticated, and I'll teach you those algorithms. Segmentation is another class of problems. The goal is to automatically classify different tissue types. So over here, this is a cross-section through a human abdomen, and I've outlined the liver. But you can see if I were to remove that red line, it would be hard to tell where the liver stops and the intercostal muscles between the ribs starts. So you have to use more. You have to use a lot of the actual shape to figure out the difference between those two tissues. Here I'm showing an MR scan of a brain, and here I've colored all the pixels to classify the different tissue types, white matter versus gray matter, and so you will learn algorithms to do that automatically, get the computer to pick up those different tissue types automatically. So we'll use a lot of calculus, but all you need really is first year calculus. Linear algebra, just first year linear algebra. Optimization, nothing special. I will teach you the optimization techniques we'll be using. We'll cover the Fourier transform, and we'll be programming in MATLAB. So just before I'm done here, I'd like to show you a little bit about how the lectures go. I supply to you these notes, but they're not complete. So you can see this is just an example from a lecture where we're talking about the Fourier transform. You see there's this gap here, and so you come to lectures with these printed out, and then I fill them in and talk about it. It's almost like writing on the board, but 2 pi I omega x dx. You can see I can't write and talk at the same time. So you fill it in, and that's how the lectures go. I think you don't have to write in all this other stuff. It's kind of a waste of time, in my opinion. So that's CS473. My name is Jeff Orchard. If you want to find out more information, please come in and see me or email me, and we'll take it from there. Thank you. Bye-bye.